Okay, so as of now, we just understand the notations of a big O, right? And big theta and big omega, right? So all of them have the word big in front of them, right? So why would someone call them as a big O, big theta, big omega if there were no small versions? They would have simply called them as O, theta and omega, right? So the very fact that they are big O, big theta and big omega means there must be something else as well, right? Yes. So there are two other interesting notation, just like we have a big O and a big omega. So the other notations are small O and small omega, right? So small omega, right? So just like we have the big O, there is something called it as the small O. Also call it as the little O, little O. This is small O or little O. Similarly, just like what we have for big omega, there is something called it as the small omega. But however, there is no equivalent of small theta. So theta stands on its own. So there is no concept of big theta and small theta. There is only one theta here. Now let us define what the small o notation and the what small omega notation. Now let me give you the definition of small o first, then we'll learn about the small omega. First, let me give you the definition of small o here. Same like how we have learned for big O and big theta, we will learn about the small o here. We say that f of n is equal to small o of g of n if and only if, so I'm just writing IFF, which represent if and only if, for all constants, that is C should be greater than 0 and there exist n0 greater than 0 such that, so I'm just writing down S dot T, which means such that my f of n is greater than or equal to 0, that means 0 is less than or equal to f of n, and f of n is strictly less than c into g of n, right, for all values of n greater than or equal to n0. So this is the definition of a small o, right? Now we need to learn one important thing here is what is the difference between the big O and the small o. So this is the mathematical definition of a small o, right? Let me repeat it for one more time. So we can say that my f of n is equal to small o of g of n if and only if, so the main important thing here is for all constants c should be greater than 0, there exists n0 greater than 0 such that my f of n is always greater than or equal to 0 and g of n is strictly greater than f of n for all values of n is greater than or equal to n0, right? So what is the difference between the big O and the small o? Let's go and understand the key differences between both of them. So in case of big O, right, as per the definition, my f of n is less than or equal to c into g of n. There should exist some constant c, some value of c here, some constant c greater than 0. So here the term sum here, and some n0 should be greater than 0 such that my f of n is less than or equal to c into g of n for all value of n is greater than or equal to n0. So this is the definition of a big O. Now what about for small o, right? So my f of n is strictly less than c into g of n. Here for all constants, my value of c should be greater than 0. So you just need to remember the term all here. There exist n0 such that my f of n is less than c into g of n. So this is the key difference between the both of them. So big O, there exists some constant c here, but for small o, for every constant c, you should satisfy this condition. So this is the very important difference you should remember. So let me give you an example so that we can understand this concept much better. So let's say I have f of n and g of n. My value of f of n is 2n and the g of n is 1. So can I say that my 2n is equal to order of n here? But I can say that 2n is not equal to small o of n, because this doesn't hold for all values of c, right? So let me give you an example. Let's say so I can write it down as per the definition. This statement I can write it down as 2n less than c into n, right? And for all values of, so I'm just using this mathematical notation, for all values of c should be greater than 0, and there exists n0 should be greater than 0 for all values of n is greater than or equal to n0. Then only I would say that my f of n is small o of g of n. But if you take the value of c is equal to 1, what would happen? So 2n is less than 1 into n. So this is not true, right? Right? So in this case, this is not true, which is not true, right? 2n will get cancelled. 2 is less than 1. This condition doesn't hold. So I would say that 2n is not equal to small o of n. But what about in case of big O? Big O. So how would we write it down, this expression? 2n is less than or equal to c into n for some value of c should be greater than 0. Let's say my value of c is equal to 3. So in this case, what would happen? So 2 is less than 3. Yes, this condition hold. But in case of small o, any value for all values of c should be greater than 0. This condition should hold. This expression should satisfy it. Otherwise, I will say that this is f of n is not equal to small o of g of n. So this is the fundamental difference between the big O and the small o. Now let me give you one more example so that you get a better idea about small o. Let's say I have 2n and n square. Okay, so can I say that 2n is equal to small o of n square? Why? Because the n square grows much faster than n, right? Again, we'll write down the expression here as per the definition of the small o. So can I say that 2n is less than c into n square? Now, if we divide n on both sides, what will be my expression? My expression will be 2 is less than c into n, right? Now, let's say for all values of c should greater than 0, right? In case of small o, let's say my value of c is equal to 1, right? And if I'm gonna take the n0 value is 3, for n is greater than or equal to 3, when I substitute the value of c is equal to 1, this condition holds true, right? This expression holds true, right? So 2 is less than 1 into 3. This satisfies the condition. The statement is correct, right? Even let me give you one more example. Let's say my value of c is equal to 0.1. Let's say my value of c is equal to 0.1. So now in this case, what will happen? Right? And what about my value of n0? So I can take my value of n0 is equal to, let's say, 21. So what is my expression here? 2n less than c into n square, and n will get cancelled. If you will divide n on both sides, you will get an expression as 2 less than c into n. My value of c is 0.1 and my value of n is greater than or equal to 21. So 0.1 into 21, that means the entire value will be 2.1. Again, this inequality holds, right? So from this example, I would say that 2n is equal to small o of n square, right? So no matter what positive value of c you choose, you can always find the value of n makes this condition true here. So in this particular example, no matter what positive value of c you choose, you can always find the value of n0 that makes the condition true, right? But so 2n square, or I would say n square, which is not equal to small o of n. Similarly, you can also showcase that 2n square, which is equal to small o of n cube, right? So you can also prove this as well, right? Same like how we have proved it right now. But again, we will learn more about all of these notations. So we have a lecture called order of functions, in which in the next videos, where you will understand much better with more examples. Here I'm just giving the definition of what small o is, but in the later video we'll understand the order of functions in detail, right? Now let me give you an alternative definition. So there is one more definition of a small o, alternative definition of small o. Let me define what the small o is, right? So let's say we can say my f of n is equal to small o of g of n if and only if limit n tends to infinity, f of n by g of n is equal to 0. So this definition comes from the calculus. You might have studied calculus in your 11th grade or 12th grade, right? And this definition is very, very easier than what we have seen right now, right? Even let me give you an example to understand this definition. So let's say, again, I am trying to prove that 2n is equal to small o of n square by using this definition. So limit n tends to infinity. What is the value of f of n? My value of f of n is 2n. What is the value of g of n? Which is equal to n square, right? So this tends to 0, right? So when you apply here, it will tends to be 0, right? Even n will get cancelled, 2 by n. If the value of n is getting moved towards the infinity, my limit value will be equal to or almost equal to 0. This we can prove it, right? Similarly, in case of 2n and n, so let me prove this statement as well. 2n is not equal to small o of n. Again, let me prove this using the alternative definition by using the limit here. Limit n tends to infinity. My f of n is 2n by g of n is n. So n will get cancelled, which is equal to 2. So this statement doesn't hold here, right? So what is the definition of small o by using the limits here? We can say that my f of n is equal to small o of g of n if and only if limit n tends to infinity, my f of n by g of n should be or tends towards the 0. But in this case, you got some constant value which is equal to 2. That's why we can say that my 2n is not equal to small o of n. So this is the limit based definition, and this is often simpler and more intuitive than